Power of landing stall. References: AFH page 4-3 to 4-8. Evaluation standards: ACS 7 task B. Specified bank less than or equal to 20 degrees plus or minus 10 degrees. Heading plus or minus 10 degrees. Conditions of flight: start at a suitable altitude. At no time should you descend below 1500 feet AGL. Downwind entry. Procedure: this is where you learn how to fly a traffic pattern and land in the sky much safer at altitude for the first few tries. CHAPS and before landing checklist. Begin a simulated downwind leg. A beam, a reference point, imaginary runway, mixture set for a climb, carb heat hot, throttle to 1600 rpm. Below VFE, flaps 10 degrees. Turn base or straight ahead. Below VFE, flaps 20 degrees. Airspeed 75 KIAS or 80 mph. Turn final or straight ahead below VFE. Flaps 30 degrees. Airspeed 70 knots or 75 miles per hour. Short final. Select an altitude to land at. Flaps fully extended. Airspeed 65 knots or 70 miles per hour. Approximately 50 feet above selected altitude, throttle idle and round out. Maintain heading or establish a coordinated turn if turning stall is desired. As airspeed decreases, altitude will begin to decrease. When this happens, begin a flare to the landing attitude and maintain this until the stall. Flight control effectiveness will decrease as airspeed decreases. So continue applying back pressure to hold the landing attitude. The yoke should be all the way aft when the stall occurs. Be patient. Recover at the stall. Power of landing stall recovery. Conditions of flight: recover no lower than 1500 feet AGL. Procedure: this is where you learn how to go around or execute a bulked landing. Reference the POH or AFM for a stall recovery or go around / bulk landing checklist, as that is this correct procedure for this airplane. When full stall occurs, relax back pressure to reduce pitch attitude. Pitch down, level or glide attitude. Power up, full throttle, carb heat cold, mixture for climb. Level the wings with coordinated use of rudder and aileron. Retract flaps to 20 degrees. As airspeed increases, adjust attitude to the horizon to minimize loss of altitude. Positive rate: airspeed Vx or greater and altitude increasing. Flaps 10 degrees. Positive rate: climbing at Vy. Flaps up. Resume assigned heading and altitude. Establish normal cruise. Perform cruise checklist. Remember, it is the pilot who caused the stall. More specifically, it was the pilot pitching past critical angle of attack (AOA). Reducing pitch back pressure will break the stall and the airplane will begin producing lift again. This does not usually require you to shove the nose straight at the ground. Be smooth and in control. Use of pitch and power. Only pitch will bring the AOA angle of attack below the critical point and get the airplane out of stall. Power helps to minimize altitude loss. It does not break the stall. As you will see, during a power on stall, you can stall with full power. With your instructor and plenty of altitude, practice recovering from a stall by just relaxing back pressure. You will notice the airplane will get out of the stall condition and begin a descent. When use power to reduce the descent and level off. By slowing down the recovery, you can see how each application affects our airplane. Use of rudder. Failure to maintain coordination, letting the aircraft yaw, nose moving side to side during stall entry will cause the stalled aircraft to roll, and you will prematurely learn about an incipient spin. Keep your eyes outside to determine if the horizon is moving sideways. Use of aileron. The wing stalled because critical angle of attack AOA was reached. Using aileron opposite the direction of wing drop, which is a natural reaction, will cause the angle of attack on the wing to be even higher while causing adverse yaw. Don't do this, as once again you may learn about spins before we get to that lesson.